So we're going to keep working on solution stoichiometry now. We saw one problem and now we're going to work a different one. So we have a new reaction here. This is a common type of reaction that you would do in lab. You use this KHP solid. This is an acidic with an H solid. This isn't actually the formula. The formula is up here for KHP. So I take that solid, I react it with a base. So acid with an H, base with an OH, and I'm going to get these products here. All right. I'm going to save this top problem for you to do, and I'm going to do the bottom one. A titration is just where you add two chemicals together. You'll see one in experiment 13 coming up. So let's read through. If 1.345 grams of KHP reacts with 24.5 mils of barium hydroxide, what is the molarity of barium hydroxide? So solutions, right? And I see molarity is in play here. I'm going to have to think through, kind of strategize this a little bit, and then get to my answer. So I'm given grams of KHP and mils of barium hydroxide. It's asking for the molarity of barium hydroxide. So I know that means I'm going to need moles of barium hydroxide over liters of barium hydroxide. And I'm pretty close, right? I've got the 24.5 mils of barium hydroxide. So it's always a good idea, just do whatever seems simple or obvious. Here's your mils to liters for my barium hydroxide, so that I'll be able to plug it in here. 1 mil, 10 to the negative 3 liters. So that comes out as 0.0245 liters of barium hydroxide. So now my conundrum is I need to know how many moles of barium hydroxide I have. And I see a mass here to help me start out with that. That's really the only other number I have left. So let's take a stab at the problem with that number. So this mass of KHP, and I'm trying to get to moles of barium hydroxide so that I can do a molarity. So grams of KHP has to be the denominator. Look up here, you were provided with the molar mass, so save yourself some work. 204.22 grams, 1 mole of KHP. And now I say, hey, I just need to switch chemicals. So where do I go to switch chemicals? Mole ratios, right? 2 KHPs react with 1 barium hydroxide. So that's 2 moles of KHP, 1 mole of barium hydroxide. And this is where I see you guys often get tempted to add a molar mass on, especially if I give it to you, you feel like you should use it. That's where you want to keep your eye on the goal. If your goal is moles of barium hydroxide, don't add that molar mass in there. I'm already at moles, right? So just stop right here. So when I calculate that, I get 0.0032930. How many of those digits should I keep? Well, I have 5 sig figs and 4. These zeros are all placeholders, so let's keep 4 plus an extra one so I don't over round as I go. So now I'm finally ready to find molarity. Molarity is going to be these moles of barium hydroxide with 4 sig figs divided by that volume that we found before, has to be in liters. When I do that, I see that I have 3 sig figs and 4 sig figs, so I should have 3 sig figs in my answer. I get 0.134 molarity barium hydroxide. Molarities are usually under 10 for most of the things that we see, closer to 1 or even smaller than 1. So as an estimate, this seems like a reasonable molarity. If you got, say, 134, maybe you forgot this step, that should absolutely be a red flag. You want to go back and check things out. So here we were able to solve for a molarity. In the previous problem, we looked for using a molarity, and you've got some other space for practice here. So you want to practice as many of these problems as you can, and you'll get better at how to strategize and set them up as you go. So practice, practice, practice.